The Dymaxion was not conceived as merely another automobile. Fuller saw transportation as part of a larger system, what he called comprehensive anticipatory design. Roads were improving, but cities were becoming congested. Cars were multiplying, yet they were inefficient, heavy, and aerodynamically crude. Fuller believed that the automobile should evolve in the same way aircraft had, toward efficiency, lightness, and streamlined motion. His solution was radical. The Dymaxion was intended to be a multi-purpose vehicle capable of carrying families, serving as a taxi, or even functioning as a modular component of future transportation networks. Fuller imagined a future where vehicles might merge road and air travel, and the Dymaxion represented a step toward that vision. In essence, it aimed to solve the problem of inefficient ground transport by rethinking the car from first principles. The Dymaxion's concept differed fundamentally from any conventional automobile of the time. Rather than evolving from carriage-based designs with long hoods and rear cabins, Fuller began with aerodynamics and passenger efficiency. The result was a teardrop-shaped vehicle resembling an aircraft fuselage on wheels. The philosophy behind the design centered on three ideas: maximum passenger capacity, minimum fuel consumption, and optimal aerodynamic efficiency. Fuller believed that the traditional car was backward-looking, rooted in horse-drawn carriage proportions. The Dymaxion, by contrast, was meant to represent the car of the future, sleek, spacious, and scientifically designed. Where most cars of the early 1930s were upright and boxy, the Dymaxion's body tapered smoothly to a point at the rear, reducing drag. Fuller even coined the term Dymaxion, combining dynamic, maximum, and tension to describe systems that achieved more with less. The Dymaxion's engineering reflected this philosophy. Instead of a conventional ladder-frame chassis, the vehicle employed a lightweight structural frame more akin to aircraft construction. The body and structure were integrated to reduce weight and improve strength, following aviation practices rather than automotive tradition. Construction was handled by Fuller's team, working with skilled craftsmen who adapted techniques from airplane manufacturing. Aluminum panels formed the body, attached to a steel frame that provided rigidity without unnecessary mass. This combination allowed the vehicle to be both large and relatively lightweight, an unusual balance for its time. The engineering challenge lay not only in building the car, but in redefining what a car could be. Nearly every component had to be custom designed, from the frame geometry to the control systems. Perhaps the Dymaxion's most famous innovation was its three-wheel layout. Two driven wheels sat at the front, while a single steerable wheel at the rear provided directional control. This configuration allowed the car to pivot in tight spaces, theoretically giving it a turning radius far smaller than conventional vehicles. The rear-wheel steering also aligned with Fuller's aerodynamic goals. By placing steering components at the tapered end of the body, the vehicle could maintain a smooth, uninterrupted airflow along its length. Weight distribution was carefully considered. The engine sat toward the rear, helping balance the vehicle's mass and contributing to its streamlined profile. Suspension components were adapted to support the unusual configuration, aiming to provide stability despite the unconventional layout. Aerodynamics played a central role. Fuller calculated that the teardrop form could significantly reduce drag compared to standard cars. Reports from the period suggested the Dymaxion could achieve impressive fuel efficiency and speeds approaching 90 miles per hour, remarkable for such a large vehicle in 1933. The original Dymaxion prototypes were powered by a Ford Flathead V8 supplied by Ford Motor Company, a reliable and widely available engine of the time. This choice was practical. Fuller wanted to focus innovation on structure and aerodynamics rather than reinventing the powertrain. The engine provided adequate performance, allowing the large vehicle to cruise comfortably at highway speeds while maintaining better fuel economy than many contemporaries. However, the Dymaxion's unique handling characteristics proved challenging. Rear-wheel steering made the car highly maneuverable, but also prone to instability at high speeds or in strong crosswinds. Later modifications attempted to improve handling and structural durability. Engineers experimented with steering adjustments and weight distribution tweaks to enhance control. Though these improvements helped, the Dymaxion never achieved the operational refinement necessary for mass production. Visually, the Dymaxion looked more like a streamlined rail car or aircraft fuselage than a car. Its aluminum body panels gleamed with futuristic promise, while the elongated windows emphasized its passenger-focused design. Inside, the Dymaxion prioritized space and comfort. It could seat up to 11 passengers, far more than a typical sedan of the era. The interior layout resembled a lounge, with seating arranged for social interaction rather than forward-facing rigidity. Fuller envisioned the vehicle as a mobile living space. He believed transportation should not merely move people, but provide a comfortable environment during travel. In this sense, the Dymaxion foreshadowed later concepts such as luxury vans, airport shuttles, and even modern ride-sharing vehicles designed for group travel. 3 Dymaxion prototypes were built, each serving as both a working vehicle and a rolling demonstration of Fuller's ideas. The cars appeared at exhibitions and public demonstrations, drawing crowds fascinated by their futuristic appearance. However, real-world operation revealed both strengths and weaknesses. The vehicles were fast and efficient, but difficult to handle in certain conditions. A tragic accident during testing, reportedly involving a collision caused by another driver, damaged public perception and halted momentum behind the project. Without financial backing for further development, the Dymaxion program stalled. The vehicles remained experimental, never reaching production, but they succeeded in capturing the imagination of designers and engineers. Of the original prototypes, none survived intact into modern times. However, interest in the Dymaxion resurfaced decades later as historians and designers recognized its visionary qualities. In the early 21st century, a meticulous reconstruction project recreated one of the Dymaxion prototypes based on original drawings, photographs, and engineering notes. This replica has appeared in museums and exhibitions, helping modern audiences appreciate the radical nature of Fuller's work. Today, the Dymaxion is remembered not as a failed automobile, but as a landmark experiment in transportation design. The Dymaxion's true legacy lies not in what it achieved on the road, but in what it inspired. Fuller demonstrated that transportation could be approached as a systems problem rather than a stylistic one. His focus on aerodynamics, efficiency, and integrated design anticipated later developments in automotive engineering. Streamlined cars of the late 1930s, post-war aerodynamic studies, and even modern electric vehicle concepts all reflect ideas that Fuller championed decades earlier. The Dymaxion reminds us that innovation often appears impractical at first, yet its influence can echo across generations. In many ways, the Dymaxion represents the optimism of early modernism, the belief that design, science, and imagination could reshape the future. Though it never entered production, it stands as one of the most daring automotive experiments ever attempted. A machine built not just for the road, but for the future itself. If you enjoyed this journey into one of the most visionary vehicles ever created, make sure to subscribe and follow for more stories about rare, experimental, and remarkable machines that changed the course of automotive history.